using the secret option key. It's a Mac. It's so simple. Well, I was going to speak with Andreas Gal, who can't be here, unfortunately. Last-minute complications kept Andreas from joining me, and I was going to use his fake real Andreas Gal Twitter account, but it's been taken down, sadly. So I only found this in the Google cache. You can try to find other real Andreas Gal tweets there. And I will not do my impression of Andreas's German accent. So you can just have my English to deal with. Thanks, everybody, for coming and staying. I'll try not to repeat things that I've said too much. The theme of the 90s makes me nostalgic for the early days of JavaScript, because even though it was a rush job, it was terribly hurried. It was done in too little time. Netscape was a blast. And I knew when it got out before VBScript that I had to stick with it to make it better, which has taken 20 years. But at least we didn't have VBScript, right? Does anyone here use VBScript? Has anyone ever used VBScript? So things take longer in the standards world, especially if the browser makers are not cooperating. Back in 1995, Netscape was the rocket that was taking over browser share from Mosaic, NCSA Mosaic. And I was tempted the second time. I foolishly failed to join Netscape at the beginning. The second time they recruited me, they said, come and do Scheme in the browser. And I believed them. But it didn't turn out that way. Now, there's an irony here in that John Carmack is using a scheme-based language, a language derived from PLT scheme and is its own Lisp dialect, very inspired by Scheme, called Racket. Carmack's putting that into his Oculus VR metaverse. So maybe we'll have Scheme for real next time. There were some tweets about this, and I tweeted back, I think it was Tony Parisi, because everybody was telling Carmack, why don't you just use JavaScript? And Carmack said I didn't have time, I'd have to do a rush job. And I said, okay, well, I did something once in 10 days, and it actually stuck. And it would be great if, in revenge for not getting to do Scheme in Netscape, we had Scheme in the virtual reality metaverse. But Carmack actually said it probably should be JavaScript. And then Mark Andreessen trolls me all the time. He comes in and says that because I was ordered to make it look like Java, that's why JavaScript succeeded. That's debatable, but at least it didn't look like Scheme. So what was it like to hack JS in 10 days? It was painful. There was a browser war, and there was no time to do anything right because Microsoft was coming after Netscape. Netscape had turned down an offer to be bought for too little money by Microsoft in late 1994, and so everybody at Netscape knew that Microsoft was coming after them. Bill Gates had written a memo about the internet tidal wave that was going to sweep away proprietary Windows stuff, and that they had to embrace, extend, and extinguish Netscape, which they'd done to other companies. They'd done it to Borland. That was the old Microsoft, so forgive and forget. God knows how. I look different then. Something is wrong with my hair. I think there's some product in it. I wasn't inspired by that. That came out in '96, I think. But there was a management order to make JavaScript look like Java. And that was because Sun was doing a deal with Netscape to embed Java in the Netscape browser. And people were going around saying Netscape plus Java kills Windows, which was kind of a mistake. I think Mark Andreessen got mail from somebody on the Microsoft board at the end of '95 saying, You've waved the red cape in the bull's face. Prepare to get the horns. And we did. But it seemed like Java was going to be the big, serious language, and JavaScript was this underfunded rush job companion language. But it got the name JavaScript. It got the trademark license. Who remembers Java? Remember that? It was different in '95. PCs were slower. They had bottle monitors. Vox says this is the last great TV season, My So-Called Life. George Clooney in ER. And I think I watched TV then, too. We had this gag at Netscape. I think Mark Andreessen bet somebody, and if he lost the bet, he would have to wear spandex and rollerblade. And so he did. And you can see him there with Angelina Jolie. I didn't rollerblade. They had roller hockey games. They were kind of violent. I didn't go into that. I did go to the Stanford University Computer Science Library, Margaret Jacks Hall. That's a picture of it. I think computer science has moved to a new building, the Bill Gates building or something. But at the time, Margaret Jacks was the place where computer science was, and the library was there, and people like John Doerr, the famous venture capitalist, said all you had to do was hang around there and you'd be a successful VC, which didn't work out for me, but I did read some papers, including one by James Gosling. And I'm glad I read it. It was not really directly relevant because it had, it was a little paper from SIGPlan, I think. It was about taking Java bytecode and generating efficient machine code quickly. A method compiler, sort of a baseline JIT, if you will. And Java has types. And so Java bytecode has types. It's kind of a mishmash, mostly typed bytecode. JavaScript was untyped. All the types are dynamic. You have to look at a value at runtime and say, is that a number? Is that a string? You don't know what it is. But one of the things that this paper inspired me to do was think about bytecode, because I was already implementing a bytecoded interpreter for Netscape, because they wanted to put JavaScript on the server as well as in the browser. They wanted a PHP-like templating language. And so here's a piece of the paper that talks about how to translate class vector into Java bytecode. And the Java bytecode has funny names that tell you if the operation is an integer operation, it starts with I. If it's a heap operation, it tends to start with A for some reason. There are double precision operations that start with D. So based on this thin relationship with Java and the incredible deadline I was given to prove that JavaScript was worth having, because if you have Java, who needs JavaScript, right? I wrote a lexical scanner and parser, and I omitted bytecode because they wanted to save that and for fast loading on the server side with their live wire JavaScript engine on the server that I wrote the engine for. And the bytecode was interpreted, and because JavaScript has toString on functions, you want to be able to get back the source for the function. Nowadays, that's done by actually saving the source, since you're always loading JavaScript to source. But back then, I didn't have a lot of memory, and I was working on 16-bit Windows, at Windows 3.1. So I wrote a decompiler. This was partly inspired by Gosling's paper that would look at the bytecode and turn it back into nice JavaScript source. Sort of did an abstract interpretation, a linear pass over the bytecode. And I barely had time to do anything nice in the standard library. I think arrays were not quite there. They were just objects with length properties. And there were array-like things in the early DOM that just had length property and indexed elements. And one thing that I had help on, somebody at Netscape hand-ported Java util date from Java to C to be part of the early Mocha engine, the JavaScript engine. And that's why we have Y2K bugs in date, like get year. It's why we have zero indexed month numbering, which people hate. It's why date is what it is. And I think we should probably upgrade date. We should probably take moment.js and standardize it or something like that. Or maybe people can just use moment. And mistakes were made. I'm the first to admit this. I will show you this amusing talk if I can get the audio on. Can we have audio from this computer? Nope, still no audio. It's funnier with Gary Bernhardt.
Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be?
Anyone?
Empty array, I would also accept type error. That is not what array plus array is. Wrong. Wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone.
It's true.
Now, what would array plus object be? This should obviously be type error because those are completely disparate types. Does anyone know what this is? No. Close. No. Far away. It's object. Right. Nicely done. Now, of course, because this is plus, so you can flip the operands and the same thing comes out. So if we do, what? No, that's just an object.
No, it's a string.
If you do object plus array, you should get exactly the same thing, which, as you can see, you do. And finally, the only one of these that's actually true is, because you add arrays, you get empty string, that doesn't make sense. But an object plus an object is actually not a number, technically. So this
Oh, well, I think my wireless died. That gives me a chance to talk a little bit about what's going on. So, all right. Yes, I overloaded plus because Java could do it because Java had types, but JavaScript doesn't have static types. So it's very dangerous to overload plus because you can end up concatenating strings instead of adding numbers. And that's, in fact, what this does. So as Gary said, that really is the empty string, and it prints properly. Where he got a little off was that's a string, too. It's not an object. Everything turns into a string that cannot be added as a number. It's the sad truth about plus, and it also applies to the relational operators with a little different preference for using numbers instead of strings where possible. And then this one, this is really good because in Gary's video, this looks like plus, but it's not. Because can anyone say what that first curly brace is? Block, exactly. So what happens is automatic semicolon insertion. That's equivalent to that. And we all know that plus is just a unary two-number operator. And plus of any object, it could be an array. But in this case, it's an array, so it turns it into the empty string, which then turns into 0. Perl did it too. What can I say? It was the 90s. It was a little bit crazy. I had people at Netscape from Borland who wanted these implicit conversions because they wanted to write code that magically did what they meant. And the problem is that the code is ambiguous, so half the time it does what you want and half the time it does what you don't want. Maybe I can get this back. Let's see. If I had, nope, we don't have any wireless here. Maybe I can get on the speakers, secret speakers network. Will it work? Oh, well, you guys can see Gary's talk. It's funny. I appreciate it, even though there are a few minor bugs in it, because JavaScript had some mistakes. And then, Brian LaRue and Andrew Lunny did WTFJS.com, I think. That has been around for years. And it's full of comedy based on these sort of implicit conversions. And I wish I hadn't done these. I had originally implemented the double equal operator, so it was strict. It was like the C double equal operator, and that wouldn't have happened. And then I was an idiot. I gave the ex-Borland people at Netscape what they wanted. I started adding implicit conversions, and it just went downhill from there. Let's see. The main thing is, in spite of all that, and people endlessly complaining like Doug Crockford, it actually is something you can get past, and JavaScript can be usable. You can use triple equal, you can use linters, you can learn the rules and survive. And there was something else I did in a hurry. It wasn't in 10 days. It was the rest of May, June, and part of July because the code freeze was coming. I did the early DOM. I did the primitive DOM that we all know and love. I'm afraid some of that is also not loading, but I think it's already loaded here. This is an example from the Internet Archive. It predates ES3, so it had to use constructors, catalog, artists. You can see it just made function constructors, and then it called them programmatically. Couldn't use JSON, so it just used the new operator and nicely indented things, and it made a little database client side. So it was a single page application where you could visit different artist pages, you could look at their pieces of art. Since I'm not on the network, I'm going to miss most of the art here. But this can be found in the Web Archive. This is from, I think, late 95 or possibly 96. I think 1996 is when the Web Archive really started capturing things. And it's too bad I didn't save some of the early work. People were doing single-page applications in 1995 using frames and frame sets, using hidden forms and JavaScript :URLs and links. They were doing purely client-side SPAs. It all was prefiguring what came later with Ajax. So we've had a lot of progress. There were things that I did based on Java and C, like put the bitwise operators in, put shift operators and the bitwise logical operators that made ASM.js possible. It made it possible to have integers expressed with definite type in the language. That was a big deal, but we only realized it much later when ASM.js, a type system for a subset of JavaScript, was written down. ES6 you've heard about a lot. It's here, right? Typed arrays came in via WebGL, which itself was originally Canvas 3D from Vlad Vukicevic at Mozilla. And then typed arrays have been adopted into ES6 from the WebGL, or the companion spec from the Kronos group, and are leading to all sorts of good things. Typed objects are coming. So in a dynamic way in JavaScript, you'll be able to write down packed data structures that lay out machine types in definite order. And you know, already people are using tools like TypeScript and Facebook Flow to do things very much like what Java did, but without all the mandatory typing. So here's an example of that class vector from Gosling's paper, written in ES6. And it has a little bit of hand ASM aspect to it to force things to integers. And you remember the bytecode from Java, there's the ASM code on the right. You don't need gotos. They actually make the JavaScript verifier, if it doesn't build extra type information on the side, it can get very confused, and you can have denial of service attacks from malformed Java bytecode that has jumps in a spaghetti fashion. Whereas nice JavaScript has structured control flow, has no irreducible control flow graphs, can be compiled efficiently. And if you use the ASM.js technique, that OR0 that forces things to be integers, if you use it carefully, and I don't recommend this, but the compilers do it, this Emscripten does this for you, then you can get the same kind of fast, precise typing that Java bragged of back in the day, and that Java programmers had to then go write down in their code everywhere. So it turned out, even though JavaScript is untyped, it has a typed subset with deterministic performance, not just machine types, but no garbage collection pauses, no just-in-time compiler misspeculation pauses, no performance cliffs. And that has led to a great many C++ programs, let's say, being cross-compiled to the web. And it's good that the compiler does this because it can add all those type annotations, those OR0s, for you. You don't have to do it yourself, and you shouldn't have to. So it's really a case of serving compilers as well as human authors, and JavaScript has risen to this challenge. People have been doing this for a while. There was GWT, the Google Web Toolkit for Java heads who wanted to write swing-like code for some reason. OpenLazlo, if you remember that. CoffeeScript, of course, but ES6 has, I think, taken away some of the perceived need for CoffeeScript. And Dart, which is now a compiled JS language, and I think better off for it. It was never going to really get into browsers as a second virtual machine. We'll talk about that more. And there's a presentation Sean LeBron did in ClojureScript I wanted to show. This is nice work that shows how JavaScript has progressed over the years. It's the sun, we're all in orbit around it. ES3 was the inner core where the hydrogen was turning into helium. Back in those days, we didn't have classes or arrow functions or destructuring or rest parameters or default parameters, but it was enough to get the modern Ajax revolution, the Web 2.0 movement going. Needed a few pieces that turns out I added in SpiderMonkey. There's a story that in 2005, I think, Microsoft launched live.com, and they liked the live name. Somebody from Netscape went to Microsoft because it used to be LiveScript, if you remember. So live.com had live maps. Live maps wanted to be like Google Maps, but it was written originally for Internet Explorer and then ported to Firefox. And the port to Firefox assumed various extensions that I added, like define getter and define setter, the early forms of APIs for getters and setters. Those weren't in Opera or Safari, so within a week of live maps launching, due to fire drills in Oslo and Cupertino, those were added quickly to KJS, or what became JavaScript Core from Apple, and I think the Futhark engine from Opera. And it shows that you can actually have rapid evolution, just like in a biological system, provided you already have the pieces lying around, the variants on the genetic material. You already have defined getter lying around in SpiderMonkey. It can be copied, it can introgress into other engines. And that's how live maps emulated the IE DOM by using these extensions. So that also shows that the way that language evolves ahead of the standards body is through extensions. And we still allow that in ECMO, in TC39. We still want engines to experiment with proposals. We just want to know what those proposals are and have some agreement and have some process for approving them. So ES5 came about that way. ES4 I won't mention, except that it's, in many ways, it's here in ES6. A lot of the things that I did, like iterators and rest parameters, were in ES4 before they were in ES6. ES5 was supposed to be no new syntax. It just added strict mode. Do people use strict mode? I think it's getting used more. And then ES6 is the big one that's with us. ES7, Sean LeBron was optimistic about predicting things here like observe, which I don't think is going to make it, but async functions and a few other things might make it. And then Sean was very optimistic about macros in ES8. We'll talk about that. But the point is, as JavaScript matures and gets on an annual release cycle from the standards body, the specs get smaller, and you can use the new version right away using a compiler or a transpiler. People are used to using these tools. They're already using them in lieu of first-class module system support in the browser, and they need it for doing things like browserify. So as opposed to 10 years ago, I think developers are now willing to use tooling, and it's very convenient with Gulp and other tools to have build steps. 10 years ago, I remember talking to JavaScript developers, and they were like, no, I will never use tools. You must let me write bare JavaScript to the metal. But that's passed without much complaint. And so now we have not only linters and sort of CoffeeScript or similar level compilers, we have real type systems for JavaScript that are informative to the standards process. I don't think we're going to standardize these as is because they're tool time. They're really only warning systems. I said they should have called it WarnScript, but that's not a very good name compared to TypeScript. There's the Clojure compiler, not to be confused with Richicki's language, Clojure. From Google, Clojure compiler is still used and it's still being evolved. It has a type system that it checks. You have to give the type hints in comments, I think. But all of this is progressing toward something that might make it into the standard. And the recent action in V8, which I think is taking longer than people wanted, is to try to do a subset of one of these type systems, something simplified from the ES4 overreach back in the day, called SoundScript, that has better rules for typing. And it has type inference, so you don't have to write types everywhere like in Java. This experiment is going forward in V8, but I think it needs more people on it. And if it succeeds, that will help us do something in a future JavaScript standard that would have optional types, gradual typing, But we don't know if this is going to happen. Meanwhile, everything keeps going. CoffeeScript's still going. Dart's out there as a compiled JS language. I like the Solar system because it actually is quite large. There's ClojureScript, which this is written in. There are a lot of languages. There are hundreds, I think, now. PureScript is a very nice Haskell-like language. There's also Elm, which is in some ways similar. And you can get any flavor of language you want compiling to JavaScript with few compromises. Sometimes the semantics aren't there in full, and I'll talk about that too. But that's the Solar system of JS. And the most important compiler there, I sort of showed it just at the end in terms of getting us to the next level on the web, I think, competing with native code, is Emscripten, because people still write C++. It's had its third or fourth life on mobile. They don't just write Java, for Dalvik or Art compiler for Android. They also write C++. Not just for games, productivity apps. Lots of apps are written in C++. Having an ability to cross-compile to JavaScript and get good performance allows people to treat the web as another port, like another Xbox or PlayStation, especially for games. And it's important that the performance be there, so the JavaScript VMs have to go down to the metal. It turns out the Java VM on the server side is doing very well, and it's got dynamic language support that started back in the DaVinci project. So I like to say the circle is now complete, though I'm afraid this makes me Darth Vader. And I guess that's James Gosling about to get sliced and become one with the Force. But where this is going is WebAssembly, and I blogged about it when the news broke. It's an unusual circumstance. It's an evolutionary success story. It also has a social aspect. All the top browser makers, engineers are collaborating on this, along with anybody who joins the community group in the W3C. So this is a case where there's no marketing or management nonsense getting in the way. It's engineer to engineer. The latest is that we have consensus from Apple, Google, Microsoft, Mozilla, AGMM. That's unusual, but the consensus is that the design repository, there's a link there, it's github.com WebAssembly design, is approaching completeness. It still may get adjusted. It's still being prototyped, so it's not frozen. There's also an executable specification written in OCaml, in the new spec repo. And Apple, Google, and Mozilla, I'm not sure about Microsoft, are actively writing prototype WASM code in their engines. They're writing code that will take binary syntax, currently co-expressive with AsmJS, and much more efficiently load it. And the reason this matters is because when we did AsmJS, we cross-compiled amazing games. I'll show you some later. But it's still JavaScript, and it's big. You can gzip it, it gets smaller, but then you have to ungzip it to parse it, and that, especially on mobile, takes a lot of cycles and battery life. So we can do better. Syntax is just an affordance, and if you wanted to express JavaScript syntax without all those keywords with bits packed together, it would take less space and take less time to load and take less battery to parse. It would compress better, too, because you're going to do transfer compression anyway. The real punchline about WebAssembly, why it happened and why it will continue to happen and evolve, is that it's not trying to introduce a second virtual machine into every browser. That was attempted with Dart, with Dartium, or with Dart and Chromium. It was very difficult, even for Google to do. You end up having two garbage collectors that have to cooperate if cycles conform to the DOM, and they can, or you have to have one garbage collector that everyone agrees on. It's like when I tried to get CPython into Mozilla years ago, which ActiveState wanted, and Mark Hammond did it, but it was able to form cycles that would leak with JavaScript. And at Mozilla, we added a cycle collector to fix this. We ended up taking CPython out. No one used it. Browsers are full of unsafe code that's hard to audit, and the browser vendors do not want to enlarge. There's no gain and pure risk in adding old implementation like CPython. Even Dart, a new implementation, was difficult. So the key insight for WebAssembly is to have one virtual machine with two syntaxes the .js, or the JavaScript source we know, and WebAssembly, which is a binary syntax. Not a bytecode in the push-down stack language sense of Java. It's abstract syntax tree encoding. And this means that we don't quite have two mouths to feed. We don't have two children. We don't have a language like Java has that's much lower level than the Java source language. When Java did that with bytecode, it ended up having compromises made because the bytecode had to stay backwards compatible, and that constrained the evolution of the language. I'm thinking of erased generics and other things in Java, and then they changed the bytecode anyway. So when you have lowering from higher level language to lower level language, and you have to keep both languages compatible, then you can really tie your shoelaces together. With WebAssembly, we're starting with WASM and JS as co-expressive, two syntaxes for the same subset, the Asm.js subset. But it can evolve from there, and it will rapidly, so that WebAssembly can express more than JavaScript can express. It can express things you want C++ to have, like full shared memory threads, which you might not want JavaScript to have. I can't really show you the binary, but there is a prototype. This is actually C++, and it shows a bunch of operator names. There's some clever things being done, like we're not actually burning these operator names into numbers. We're letting different WebAssembly files optimize for the operators they use and give them their own numbers in a local section, so that over time we can change the number of operators and not break compatibility. We've learned a lot by having JavaScript be a source language where you use names instead of numbers, and so we're preserving some of that. And this shows a lot of opcodes. There's constant ones, the lit pool and lit immediate for a list of constants or a single constant. There's get local, get global, set local, set global. They have oddly shortened names. You'll notice signed and unsigned load instructions. So this is low level. It's like what you do in JavaScript with typed arrays, uint8 array, uint16 array, uint32 array. Call instructions, the conditional operator, the ternary operator, the comma operator, some conversion operators from F32, from F64. All the math operators you know from JavaScript, right? That's unary minus, it's binary plus, binary minus, star for multiply, etc. Some signed and unsigned splitting there for the division ops. Then there are the famous bitwise operators that I'm glad I added. And there's count leading zeros, so there's some math extensions coming along in ES6 that are helping not only Asm.js but WebAssembly. There's the tilde operator and the bang operator, and a bunch of equality and less than operators. I skipped some of them. What does this look like? I wanted to show you some more C++ without turning this into a C++ conference, to show you how this turns back into Asm.js in the prototype polyfill, so-called. So you load this binary WebAssembly and you turn it back into JavaScript. But what do you do? If you want to convert from 32-bit float to a 32-bit integer, you just use good old tilde, tilde, two tildes. That does one's complement in 32 bits. That's the shortest and most compact way, because you don't get a binary operator like or zero. You have to parenthesize to convert from a float or a double to a 32-bit integer. And I should mention, there's not only I32 opcodes, there are F32, there are I64, so 64-bit integers are part of WebAssembly and should be part of JavaScript in ES7. And there's F64, of course, the double precision we know and love. So there are a lot of opcodes. I only showed a slice of them, 4 of them here for I32. And neg, the unary negation, is just minus, and bit not is tilde. So I'm going to skip this because you've all had a lot of ES6, and I don't think we need to go on about that. But I did want to show a few things that are coming. Since we're trying to get on an annual cadence, we've actually renamed the ES6 spec to be ES 2015. It's out. It has bugs. It's like any piece of software. So there are errata being compiled for it. The implementers will use the fixes instead of the bugs in the published spec, and those will be rolled into ES7 2016, ES8, and we'll keep going. One thing I think should happen, I think the committee's pretty serious about this, is async functions. So people here use async programming. How many people use promises? Here's an example showing promise chaining. to chain animations and propagate sort of return value from one animation to the next. And it's a little painful because you have to write p.catch and p.then. You can't write try-catch. You can't write normal control flow. You have to use callbacks, like this function being passed to then. So in ES6, there are generator functions, and there are coroutine libraries like task.js you can use to make this a little nicer. Then, instead of the for loop making a promise with a then call that passes a function as a callback, you can write inline code and straight line code, and you can use yield. You can also use try-catch because the right thing happens when an exception is thrown at a yielded generator. But you still have to write a generator, and it's a little funky. So in ES7, we would like to support custom syntax, async function, and inside an async function, you can use await. You see that there in the place of yield. And now you not only get normal and exceptional control flow using the normal statements, you also get no generators, no task.js or other coroutine library. You just get built-in async functions and async await, which is in Dart and C#, if you know that. It seems like the right thing. I think this should make it into ES7. And there's more coming. Some of this won't make it because we're going to not play schedule chicken. We're going to say if it's not ready, it goes into ES8 2017 or ES 2018. Some of these things need to get going, though. And SIMD is actually in very good shape, but it's probably going to take another year. I'd like to get int64 and uint64 in. I think it may come into the engines ahead of being in ES 2016, maybe ES 2017. You shouldn't worry about the specs now. You don't have to wait for the spec to be finalized. If the proposal's in good shape and the engines are implementing it, it should start to get to the process stage 3, I think, where it can be not behind a flag, not only in nightly builds of Firefox or behind a V8 flag. So some of these things like operators and literals probably won't be in ES7, but they're on the roadmap. And async generators are an obvious extension of async functions. I also wanted to talk about macros because Sean LeBron did. There's a project that Mozilla Research, Tim Disney did called SweetJS. And it's really cool because it's a tool-time macro system, hygienic macros for JavaScript. And it allows you to do things like make a class before ES6 or Babel or other transpilers existed. And Sweet can do destructuring, it can do all sorts of amazing things. Probably not going to be standardized as is, but it's very informative, and it might lead to macros in JavaScript someday. I hope so. It's awkward to have to keep adding syntax to the language just for convenience. We try not to. If you can defer adding syntax, you can avoid making mistakes or committing to something you might want to change later, even if it's not a pure mistake. But we've added syntax. Arrow functions are really good. They're very convenient. Destructuring is good. So if we get macros in, I think the committee is then done. Everything else can be done through macros, which you can load. The world doesn't need endless syntax to be customized into the language if the users out there, if you can program them through macros. And I'll do a few demos. I think you've probably seen some of these. This is a picture from a rafting trip at Netscape. Some of us got stuck surfing a whirlpool and got pulled into the water, so I had to wear a shower cap in honor of that. Yeah, I think I'm off the network here. Let's hope some of this works in spite of that. I think I have it cached. This is a Unity game. So Unity is now, through ASM.js and WebGL, supporting the web just like another port, like an Xbox, PS4, whatever. And it works well. It's a little big. That's why we're doing WebAssembly, but it loads pretty quick once you have it cached. The best part about this game is the sentry chickens. They'll take care of any zombie problems you have. I really like my chickens. But the machine guns overheat and explode, and chickens blow up. It's very sad. There's a cloud of feathers. But they respawn. In the meantime, I can try to get an extra... Oh, there's a golden pig. I don't know why the zombie game has golden pigs, and you get extra money. Also, the zombies are carrying a lot of cash around, too. Who knew? It's expensive being a zombie. Okay, that's enough of that. And this is a game I have locally, so this will work. This is another game that is on the Unity platform, Unity 5, called Prime World Defenders. It's a tower construction game. I'm not very good at it, but you can see that loading was a little bit slow there. WebAssembly will make it really fast, like 23 times faster, I think Nick said yesterday. This is, I think I'm a ranger. There's some Doug Crockford graybeard telling me what to do. Story of my life. All right. Yeah. Don't do implicit conversions. Oh yeah, I can build a tower. Okay, thank you. Simple and cheap. All right. Is it trying to upsell me something? I'm going to do it. Towers. And thank you. I read that. Towers. Here comes the first wave of kobolds, I think they are. I don't have to do anything, but I'm going to make this go faster. So 2x? No? How do I do it?
Don't forget to build towers, remember.
Yeah, don't forget to build towers. Thanks, Doug. There, I'm going 2x. It's faster. And now there's some, like, dark elves or something coming at me. Pretty soon I'll use magic. This is all running in real time. It's not melting my laptop. Thank you. I'm going to use some sticky slowing tower mixture. Thank you. All right. Anyway, it's cool to see games. It proves some amount of competence for the web to be able to do WebGL-based games. There's still a lot of things we'd like to be able to do better, like use less memory. Come on. All right. Enough of that. This is not my favorite game, but it's just one of many games now that are out for the web thanks to the AsmJS work at Mozilla, which then Microsoft embraced and adopted in Edge, in Chakra, in their JavaScript engine, and which is also supported in V8 Turbofan. And Philip Pietzel at Apple likes to say he can make AsmJS code fast without having to even recognize it as such, so good for him. More power to him. And that's, again, paving the way for WebAssembly, which is why I always end these talks with a 90s homage. No. Always bet on JS. I think I had to update this to WebAssembly because we'll have a target language for everybody else to use. C++ now, other languages down the road. You won't have to compile to JavaScript. We can have one VM with 2 syntaxes and more semantics than we want to burden with poor old JavaScript. I did JavaScript, and I did not plan for it to last 20 years. It's definitely funny to me that it has. There are reasons for this that are kind of obvious in hindsight. It was early enough that it got everywhere. It got fast enough. It was not too brain damaged. It's the thing that you can't really replace. So if you're going to do something else, you have to do 2 things, and that can be very hard unless you share the same VM, which we're doing at ASM. So always bet on JS. Thank you very much.